Okay, look for something that says live stream. There should be one that says, like, it's red, though. It should say it's live.
No, I might have to refresh. This one?
You could do
It should say 2.6 on it. You should see 2.6, blah, 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 multiplying, rational, yada, yada, yada.
It'll be more soon. Just so like how that like hi guys and they'll show up.
Yo.
I go like.
Get ready to make a beat. Yeah, see what I did there?
So you hear it.
Yeah, I know. It was delayed, but I said something. I didn't hear it. Kick him out. Kick him out.
I was like,
I'm having all these issues with iPhone users. So are you signed into your own account? So you have to sign in. If you're using Chrome, you have to sign into your Google account. I don't know if they changed.
Yeah, I don't think you want to.
I didn't think so.
No.
Okay. You sign into.
do you see you guys have the live stream? You guys have the live stream yet?
It's like, it's so delayed.
Oh, it sounds. No, like live stream. Did you see that? I didn't want it though. So,
It's probably 10.
oh.
Are you in yet?
No, do you want the internet or? No, 3G. What if I watched a courtesy like a big one, 3G.
Good. Okay, folks, so it's going to be a little bit awkward, but this is the best I can do with what I got. Thank you for that there. Echo, echo, echo. Okay, if there are any questions from yesterday, let's just try and skip it. We'll come back to it later just because that's going to take up too much time. Love it.
So how long is the delay like before you switch to 45 seconds?
Yeah, this was around 45 seconds, but it depends on device and internet connection.
So should we just like mute this then? Or what?
You're probably better off at muting it and just watching the content. You'll be able to hear me. I'm right here.
So are you going to do one of these every class?
No, so what I'm doing, I'm actually doing this for my e-learning course. So for the people that are in my chemistry class, I'll be sitting in a room doing this, and they can watch the live stream of it. There's also a chat session if you're using a bigger device, like a computer or something. There's like a chat section, so you can type in the chat, and I'll be able to see it. I can pull it up on my, if I open up YouTube, I'll be able to see the chat and be, oh, please go over that again, and I can redo that section. Okay, so what do we got here? Oh,
Let's go over this stuff.
I just said we're not going to. We will after. So, Toulier is telling Daisy about something that her chemistry teacher was demonstrating. It was about the variables x, y, and z. I didn't catch how x, y, and z are related. Tell me how the units of the three quantities are. Or what they are, sorry. They were moles per liter second, liters per mole, and second to the -1. I have no idea what any of those mean. I guess I have to look for help elsewhere. Hold on, blah, 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 like what? So, how are the three quantities related? Anyone know how they're related? Most of you are in chemistry in this exact room. It's kind of funny. My phone's going crazy because everyone's subscribing now. We can cancel units. I don't know if you've probably done this in chemistry or not, but you can cancel units if they're on the top and the bottom, just like we can in math. So if we look at moles over liters and liters over mole, well, we can get the moles to cancel. We can get liters to cancel, which just leaves us as 1 over S. Now, how is that related to S minus 1? Does anyone know? Does anyone know what this means, the power to minus 1? What? Close, but no. Close. When it's a negative, it just means you put it in the denominator. So you keep the same number, just put it in the denominator. So this is equal to 1 over S to the power 1. What you're thinking about is you would have that times 10 to the power of negative, and then you're correct by moving over decimal places. So you're partway correct. So S to the minus 1 is equal to 1 over S to the 1. Similarly, if we had S to the minus 4, what do you think that's going to equal? Well, following the same pattern, it means it's 1 over S to the positive 4. So it's just a way of getting rid of that negative, or by having a power in the denominator and moving it to a power in the numerator. So, using multiplication to show the expression that moles over liter second and liter per mole is equal to S to minus 1. So if we take moles over liters per second and we multiply it by liters over mole, let's see what we get there. Now, when we multiply two fractions, so if we have A over B multiplied by C over D, can everyone see that, or do I have to wait a little bit? Okay. At what point can you see? So, about 10 seconds? Okay. Okay, so everyone should see the fraction of A over B multiplied by C over D. It's 10 seconds. Oh, it's because you're iPhone users. Yeah, it's going to be longer. So everyone should see it. So what is A over B multiplied by C over D? We can make that into a single fraction of AC over BD, where A is multiplied by C and B is multiplied by D as well. Now remember what we did yesterday. When things are multiplied, what can we do in the numerator and the denominator? We can cancel if they're the same. So had this looked more along the lines of AC over BC, what can we do with the C's? We can cancel them out to just give us A over B. So now let's apply that same principle to the question that we have in front of us. So the moles over liter second multiplied by liters over mole. Well, we can change this to moles times liter over liter times second times moles. Try touching it. Yeah, try going out and go back in. Good? There you go. Thank you.
How did you get the mole times
It says use multiplication, so that's multiplying, to show that the expression, the first two, and how the third one is related. So I know that multiplying the first two will give me the third, so I'm just doing that. Yes, but the thing is, the projector may work, but my computer isn't touch screen sensitive, so I have to use the mouse to write. So, and it takes forever. So this is pretty much the same idea. I was hoping, because I was kind of excited, because if we had the Chromecast, I could open up the YouTube Chromecast over here so we could use it all, everyone could see it, but the Chromecast isn't even connected here yet. There's one connected in our classroom, but... Okay, so since we have everything multiplied on the top and everything multiplied on the bottom, now what's the thing that was missing that stopped us from canceling things yesterday? Inside one of the brackets we had an adding and subtraction. Since we don't have that, we can cancel anything freely. So we can cancel the moles and we can cancel the liters. Therefore, that leaves us with 1 over second. And say, how do we say that was related to second to the minus 1? How are they related? They were exactly the same thing. 1 over second is equal to second to the power of minus 1. Anything to the power of minus 1 is just 1 over itself, or anything to the negative power n is just 1 over that item to the power n. So I'll let you see that, and then we can talk about it if you have any questions.
So, it's like the inverse graphing. That also be like the example x to the power 2.
That's exactly correct. So 1 over x would be x to the minus 1. That's the exact same graph. Okay, and that's how they went through the solutions. Now, I want to bring up this point. If we go back to the solution page, so just tell me when you can see Luke's solution. Okay. Now, with Luke's solution, because they are multiplied, and the way that fractions work, you multiply everything on the numerator and multiply everything on the denominator, we don't literally have to put them as a single fraction. We just need to know we can apply the same principles. So if there's anything in the numerator of one fraction and the denominator of any of the other two fractions, you can cancel them out. So you don't have to put it all together. So here they've got the moles over the liters second and multiplied by liters over moles, and they've canceled those two guys out, because one is in the numerator and one is in the denominator. Same thing with the liters, they cancel one out here and they canceled one out there, leaving us with just 1 over second. Then they found that the relation between second to the minus 1 was actually equal to 1 over second, so therefore they found the relation, how those three things were related. Moral of the story: if you don't have pluses and minuses in between things, if it's just the objects by themselves, we can cancel very easily. If you have two sets of fractions, I don't want to use chalk. So just tell me when you see a fraction. Okay, so if we've got this, we can write this as a single fraction with all the things on the top and all the things on the bottom. Or we can realize that we can just cancel things, because that will be the end result. So what can we cancel in this question? So we can cancel the C's and we can also cancel the A's. So then our resulting multiplication will be BF over DH. Okay. So go ahead and try this question that you should see, example 2. Multiplying and dividing rational functions. Pardon? Yeah, that's the only way to cancel, if one is in the numerator and one is in the denominator. They don't have to be on. They don't have to. Sorry. No, they can be directly over top of each other. They can be on the diagonal. Just one has to be in the top and one has to be the bottom. Peyton, but we're gonna go live in period 3. So if you want to tell the rest of the goons, I'll probably drop by just to tell them. But I don't know if there's gonna be a quiet space in the corner. Anyway, when you have a result, put up your hand and I'll come check it out. So the same thing applies with numbers. Oh, 6 and 8. Okay. Yes, 6 and 8. What's common to both 6 and 8? Is the question very small, guys? Like, is it hard to see? I can. Oh, I can't. Hold on. That should make it larger. Put it all together and still can't. As long as one's on top and one's on the bottom. For the 5xy, if you are completed, go ahead and put any restrictions as stated in the question. What do you mean by restrictions? From the original example. Where do restrictions come into play? Nope. Ah, yes, you could have saved them on the back. So restrictions come when the bottom cannot go to 0. If the bottom goes to 0, then you get undefined. So you're basically looking at when can the bottom not go to 0. When y squared equals 4? No. So if there's everything's on the bottom is multiplied. So you have a number, you have x, number multiplied by x multiplied by y. If the bottom goes to 0, what would have to be true about x or y? They couldn't be 0. So that's your restriction. So either x can't be 0 or y can't be 0. Okay, so following through again with the delay, I'm going to start with the y's. Most people start with the x's. I've got 3 y's on top of 4 y's. So I can get rid of all my y's on the top and get rid of 3 on the bottom. That leaves me with just that 1 y. Right beside it, I have an x over top of an x, so I'm going to get rid of that. In my first one with the 6x squared over 5xy, I've got 2 x's on the top and 1 on the bottom, so I'm going to get rid of 1 x on top and 1 on the bottom. Now let's look at the numbers. The numbers happen to be more on a diagonal. 15 and 5, how are they related? Well, 15 is just 3 times 5, so I can take out a 15 and the 5 and leave a 3 up on top. With the 6 and the 8, there's 2 in common. So I can cross off the 6, leave a 3, and cross off the 8 and put a 4. So I'm left with 3x over y multiplied by 3 over 4y. Well, putting this all together will give me 9x over 4y squared. I didn't find my nest. The nest is the place. So restrictions, it says state any restrictions. So again, we can't let the bottom go to 0. So therefore, x cannot equal 0 and y cannot equal 0. Okay, go ahead and try example 3. I'll make it bigger here in a quick sec. This one's a little bit more involved, but still not impossible. So how is this one different than the previous one? Root function? Squared? Oh. So we're going to have to do, if we see that thing squared and we see this x squared plus 9x plus 18, that indicates we have to do what with that? The opposite of expand. Factor. It is? What kind of, that's a special quadratic. It's a difference of squares. Yep. Nope. You're going to want to keep everything that's factors one, because those factors are what's going to cancel, or parts of factors will cancel. Answer. That is in factor form is the other factor. Like, okay, who's here? Almost. They're not quite the same. How is this so different? Negative other thing. That's the thing. Or put out a -1 and just flip the other two. These are big devices. Okay. So if I pull out -1, -1 times what will give me 2? -2. -1 times what will give me -x? Positive x. So this is actually equal to. They're all multiplied, right? This is multiplied by 2. What's 2 times -1? That much. Does anyone have any questions? I'll give you about a minute. What is the answer?
What was the last step in this video? Almost right to the last step. It's really like that. It's not really.
I think the question also says, the restriction. Go ahead, see the restriction. If you're ready. Negative 1 over 6 and 1 over 3. His factor is right. These all come from the original. So if you notice, this factor form ends up giving you my actual 6 product. So that's already there. And my sure when it's out, already well, minus 2 can be 0. So the x plus 6 is already in there. You always go back to the original. Always go back to the original, yeah. So when you're looking for your restrictions, you can go to your original equation, but you can go to the second part where you just put it into its factors. It's easier to make it easier to find the bottom going to 0. Yes, you have to actually do it like this because it's usually better. Okay. So I can. So this is 0, and this is 0. I'm not going to solve for x. Solve for x and x plus 6 squared and 0. Squared on the top. And there's what x on 0. What would make this go to 0? What x value would make this go to 0? Okay, so I since x plus 6 okay. I think most people are getting it, so we're going to go ahead and plow through. Okay, so I realized the one on the top left can factor. It's a difference of squares, x plus 2 times x minus 2. All over, we're just going to leave it as x plus 6 squared. Multiply. The quadratic on the top right can be factored as x plus 6 times x plus 3. All over 2 times x2 minus x. Now, if we notice this 2 minus x and this x minus 2 are close, but they're just off by a little bit. They're off by that negative sign. By doing the negative sign, you switch the two variables, x and 2. So I factor minus 1 out. What I'll be left with, I'm going to do with the x first. So minus 1 times what will give me minus x? X. Very good, class. Minus 1 times what will give me positive 2? Well, it'll be minus 2. So notice now that the factors are the same. Again, we can cancel any factors that are the same. So we got an x minus 2 and an x, x plus 6 that cancels. So I can just take off the 2. So then our resulting fraction or rational function will be x plus 2 times x plus 3 over x plus 6 times minus 2. Now, some people said, oh, the answer in the back of the book or the answer in the book said have the negatives on the top. Well, it doesn't actually matter where the negative sign is. Negative 1 over 2 is the same thing as 1 over negative 2. Oh, restrictions. So restrictions come from when the bottoms go to 0, or not go to 0, if you will. So what would make x plus 6 equal 0? What value of x? Minus 6. Yeah, so x can't equal minus 6. And what about for 2 minus x? What value of x would make that go to 0? 2. So x can't equal minus 6 and x can't equal 2. Now, this next question, just let me know when you see it. Oh, and I'll zoom in. Okay, can everyone see the question and it's zoomed in? One person. Okay, so everyone should be able to see it there now. What's the difference between this one and then the last question? Ah, there's a division in the middle. Does anyone know what to do with that division and how we can change it? Nope, can't cross multiply because it's divided. Multiply by the reciprocal. What that means is we can put a multiple sign, but we've got to flip the fraction on the right. So what we can do is we can rewrite this as 21p minus 3p squared over 16p plus 4p squared multiply, and we're going to flip the bottom and the top and write the fraction. So it'll be 12 plus 7p plus p squared over 14 minus 9p plus p squared. Once you're at that point, then have at it. Does anyone else have any other questions?
Yeah, there's actually, there is some sort of play that people feel like even if you're coming in later, you can put play with it. So like, yeah. Yeah. The software that's very popular is something that people do in casting. So it's like wow and stuff like that. You know, they're watching videos of people playing games. So not playing. Because what do you do in this that is what happens? If we get back to the change the factor you have to factor quadratics so you get binomials. Factor something of this, factor. So what's the factor of this? Let's look at this common word. 3p and 1p left. That's right. When you factor, you're taking something and putting it into brackets. And then
Okay, I think most people have an answer or well on their way to an answer, so I'm going to go ahead and continue on with this. So from my first factor, or first to the top left, I notice that I can take a 3 and a p from each, leaving me with 7 minus p on the top. On the bottom, I can pull out a 4p, leaving me with 4 plus p. Factoring the top right, I am going to get 4 and 3, so 4 plus p and 3 plus p. And on the bottom, I'm going to get 7 minus p and 2 minus p. Which 4 plus p? So I notice that I can take a 3 out from each. Yeah, go ahead. 3 from each. And there's also p in each. So I can take 3p from the top. So 3p times what will give me 21p? On the other side? What two things multiply to give me 12?
you just do that backwards?
Yeah. If you want, change it the other way. It doesn't matter. 4 plus p is the same thing as p plus 4. Yep. So now looking at the things that cancel, I get a 7 minus p and a 4 plus p. Now, what can you tell me that you're noticing that happens every time when you do your factoring? So there's going to be one of your factors going to cancel with one of the ones that's in the bottom. Same thing with, or vice versa if it's on the top. So for my first example, I had a 4 plus p on the bottom. So I knew that 4 plus p had to be a factor on my other side, on the top. 7 minus p was a factor on my top left. So therefore I knew on the bottom right it's going to have to be a factor of 7 minus p in there as well. So final answer, and I can do one more cancellation. The p's are common on each side. So I'm left with 3 times 3 plus p over 4 times 2 minus p. So restrictions. So we're looking at restrictions. So I'm going to go to my first factored form. So here are all where my restrictions are going to be. So each one of those things in brackets, what would I need to do to make those go to 0? So what about 4p? What would p have to be in order to make 4 times p equaling 0? What would p have to equal? 4 times what equals 0? The amount of comments that are spoken right now. 0. That's right. What about 4 plus p? What would p have to be to make that go to 0? Minus 4. 4 minus 4 equals 0. What about 7 minus p? What would p have to be in order to make 7 minus p go to 0? I heard it. 7. 2 minus p. What would p have to be? 2. So those are our restrictions. That is. So it is from original. It just, you go to its first factored form because then it's easier to find them. If you put 2 into the equation on the bottom right, so 14 minus 9p plus p squared, you're going to get 14 minus 18 plus 4. That gives you 0. 2 and 2. So that's our original equation. Nope. Put 2 into 14 minus 9p plus p squared. Because we said that 7 and 2 were the factors. So if we put 2 into that equation, we get 0. So by going into its factored form, we see, 7 minus p and 2 minus p. But it's easy to figure out what p needs to be in that case. All right, in summary, the fraction of a over b multiplied by a over c is equal to ac over bd. The restrictions are that the bottoms can't go to 0, so therefore b and d both cannot be equal to 0. Also, if you have AB divided by C over D, well then you can leave AB and you can multiply by the reciprocal. What that means is you take the second fraction and flip it upside down. So you're going to get A over B multiplied by D over C. That gives you AD over BC, and therefore B and C as well as D cannot equal 0 because in our original equation D was on the bottom. Okay, so your homework for tonight is located on D2L. So this is actually a good opportunity because it'll force you to go to D2L. On D2L, under Chapter 2, you will find under the assessments and assignments, Chapter 2, assessments, assignments, and it'll be Probably like multiplying and dividing rational functions. Nope. Just do the questions. It's probably called multiplying and dividing rational functions. I will try and go do it here myself. Before I go, is there any other questions about this stuff? No? Okay. Well, thanks for watching and participating in this live stream of this crazy lesson today. Oh, bye!